Bisectors in a triangle, points of concurrency. Vocab. Concurrent lines, three or more lines or rays or segments that intersect at the same point. So when you have three or more lines intersecting, crossing at the same point, we call that concurrent line. Point of concurrency, where the three lines intersect, the point of intersection, we call that point of concurrency. Perpendicular bisector of a triangle. A line or ray or segment that is perpendicular to a side of the triangle at the midpoint of the side. So what it looks like. When you have a ray or segment that is perpendicular to a side, right here, this line is perpendicular bisector, which is making a 90-degree. And if it's going through a midpoint on this side, we call this perpendicular bisectors. Remember, bisect means it cuts this side into half and half. Okay, so they're same here and same here. So this line is perpendicular bisector. Perpendicular bisectors. The three perpendicular bisectors are concurrent. Point of concurrency can be inside, on, or outside of the triangle, depending on what type of triangle it is. For example, if you have three perpendicular bisector, this green one is the one perpendicular bisector for this side. This blue one is a perpendicular bisector for this side. This red one is perpendicular for bisector for this side. So it has three perpendicular bisectors meeting inside. If they cross and intersect and meet inside, this triangle is acute triangle. Acute triangle has three perpendicular bisectors that intersect inside of a triangle, always. A right triangle, if you draw a perpendicular bisector here, here, and here, they will meet on the triangle, like on this hypotenuse right here. Okay, so it happens when you have a right triangle with three perpendicular bisectors. They'll meet, intersect on the triangle, on the middle, on the midpoint of this hypotenuse, always. When you have an obtuse triangle, if you draw a perpendicular bisector, they're going to intersect at the outside of this obtuse triangle. So acute triangle means all three angles are less than 90. Right is one of them is 90. Obtuse is one of them is more than 90, 180. So this is an acute triangle. This is right triangle. This is obtuse. When you have three perpendicular bisectors, each triangle has three perpendicular bisectors. When they intersect, when they meet, it's going to be inside for acute triangle. It's going to be on the hypotenuse midpoint for right triangle. They're going to meet outside of obtuse. If it's obtuse, it's going to be outside of the triangle, always. Okay. The point of concurrency for the three perpendicular bisectors is called circumcenter, and this is a very, very important vocab. And concurrency of the perpendicular bisector of a triangle theorem. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. How do I remember it? So the circumcenter is equidistance from the angle. And what it looks like, PB equals PA equals PC. So I'm going to have you copy this and I'm going to explain. So where these three perpendicular bisectors meet, right here, this intersection point, this intersection point, we call that circumcenter. Okay? So here, when you have this triangle, you're gonna have this triangle A, B, C, and this P is the circumcenter, where three perpendicular bisector meet. That's the circumcenter, P. And then from P to B, this is the vertex. From P to A, that's the vertex. From P to C, that's the vertex. If I draw a line from the center to here, 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 these three lines are equal distance from here. So they're same. If this is 5 centimeters, that's going to be 5 centimeters. That's going to be 5 centimeters. And you draw a circle. That's why circumference. Circum is like circumference, and then center. So that means what you're going to see is this is actually like a radius of this circle. If I draw a circle around this triangle, and if I have perpendicular bisectors from each triangle and put a dot, this is going to be the center of a circle, and this is a radius actually of the circle. Anyways, so this location is called circumcenter, and from circumcenter to each vertex of the triangle is equal distance. They are same distance. And the circumcenter is an equal distance from an angle, from the angles. So P and B, this right here, is equal to PA equal to PC. So please write this down on your notes right here. PB equals PA equals PC. Same distance, okay? So you don't have this paper on your notes, but we're going to actually write this down on an index card. I'm going to give you an index card in class. So we're going to write circumcenter, and you're going to write that in the front of the index card, and in the back we're going to write formed by perpendicular bisectors. So you need to know that perpendicular bisectors meet in the middle or on or inside on or outside of a triangle. We call that point circumcenter. And where is it? If it's acute triangle, if it's inside. If it's right triangle, it's on. If it's obtuse, it's outside. And what's special? Equal distance from the vertices, the angles. So circumcenter, they are equal distance from each vertex of each angle of a triangle, like this. So equal of vertex from the triangle, okay? So let's take a look at the example 1. 3 people need to decide on a location to hold a monthly meeting. They will all be coming from different places in the city, and they want to make the meeting location the same distance from each person. Explain why using the circumcenter as a location for the meeting will be fairest for all. So here we're going to have A, B, C. They're all coming from different city, right? Now, why is it fair to use circumcenter as a location for all of them to meet? Because it is equal distance from each person. So if I draw a triangle like this, okay, and if they meet in the circumcenter, that means it's going to be equal distance from B to this point, A to this point, C to this point. If I have a circumcenter, definition of circumcenter is equal distance from each vertex of a triangle. So that will be fairest for everybody. So please write this and draw this. Now we're going to look at something different now. It's called angle bisector of a triangle. A bisector of an angle of the triangle. The point of concurrency for the 3 angles bisector is called incenter. Always lies inside of the triangle. What it looks like. So what this is when you're using angles of each triangle. So you look here, this green line is a bisector for the angles. So if you draw, It bisects this angle into two equal parts. And then this red line is a bisector for angle. We're talking about angle for this angle. This is the bisector for this angle. And when you draw each line bisector, the point of concurrency means where they meet, where they intersect. We call this in center. It's always inside of a triangle, in center. Okay? And here, same thing. Angle bisector, angle bisector, angle bisector. You have three angles in a triangle. That's why you have three angle bisectors, right? Where they meet, that point of concurrency is called in center. It's always inside. Okay? So the difference between the circumcenter is that they're using perpendicular bisectors and they meet at different position right here. But then for in center is always just using the angles, bisecting the angles, angle bisector to and then it's always inside. So I'm going to show you here the angle bisector, concurrency of angle bisector of a triangle theorem. The angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle and what it looks like. So this green line is a angle bisector because it's bisecting this angle. This blue line is an angle bisector. It's bisecting this angle. And then this red line is an angle bisector that's bisecting this angle. So remember, bisecting means equal, it cuts angle into two equal parts, okay? Always remember that. This is same as this. These are congruent. So what it's doing is that when you have in center, this P is in center. From this in center to this point, okay, from the side, is equal to this side right here and then this side right here. If I draw a perpendicular line from this in center to the side of each side like this, perpendicular, has to be perpendicular, this B, C, CA, so PA is equal to PC is equal to PB. So they are equidistant. Okay, so this is the in center from the angles. And then from here, if I draw a perpendicular line to a side, this side, and this side, let's say this is 3 centimeters, that's going to be 3 centimeters, this is going to be 3 centimeters. They are equidistant. Okay, so this is the concurrency of angle bisector of a triangle theorem. So when we come back, we're going to write this on a note card, like an index card. So in center is formed by angle bisectors. And where is it? Always inside. And what's special? Equidistance to the sides of each of the triangle. So there are two theorems that we have to remember. Concurrency of a perpendicular bisectors of a triangle theorem. The perpendicular bisector of a triangle intersect at a point that is equidistant from the vertices of a triangle. So if you have a circumcenter right here, okay, they are same distance, okay, from each vertex, from vertices, okay, that is the theorem. And then this theorem, the second one we have, when you have angle bisector, we're talking about angle bisectors, okay? These lines, green, blue, and the red, that is going to be equidistant to the side. This side, this side, this side, if I draw a line, okay? Perpendicular. So that's the two theorems that we have to know.